Hi everybody, today we're looking at alignments of graphs, which is where we draw the derivative or the second derivative when we're given the function, or when we draw the original function when we're given the derivative. And so this first page in the notes isn't the main part, but it's just a summary of everything we've done so far. So I'm not going to go through it per se, but I would encourage you to read it and to make sure that there are no surprises there. It should all have been work we've done. The easiest way to teach this is to actually just do examples. And I've got the process on the left side and I've got an example on the right side. So here we're looking to draw the function, rather the derivative and the second derivative, given this being the original function. So the first thing we do here is we identify stationary points and we mark them as 0. So very first step, identify stationary points and mark them as 0. So stationary points are points where the derivative or the slope of the tangent is 0. So if I go through, I can mark 3 stationary points and I'm marking them as zeros. Then I want to draw a sign diagram of f dash of x. Well, as I've got there in the process, f dash of x, if f of x is increasing, then f dash is positive. And if it's decreasing, then it's negative. So in this case, to the left of a, f of x is increasing. Between a and b, it's decreasing. Between b and c, it's increasing. And then from c onwards, it's also increasing as well. And so we get this sign diagram, which is going to be very useful for us. Now we consider inflection points of f of x, so where it changes from convex to concave. So there'd be one, and we're going to have to guess a little bit here, but there'd be one about there, and then there'd be one about there, and then there's another one at C as well. So if f of x goes from being convex to concave, then it's going to be a maximum, and if it goes from being concave to convex, well, it'll be a minimum. So in this region here, we're going from concave to convex, so it's going to be a minimum, and in this region, it's also negative. So my derivative is negative, so it's going to be somewhere down here. Now here, my other one is here. Here's where it is positive between B and C, and it's going from convex to concave, so it's going to be a maximum somewhere around about there. And we've also got a horizontal inflection point there, and that's where it is going to touch but not go through the x-axis. And so now we're ready to draw. So to the left of A, we said it's positive, so it's going to start up here, it's going to come down, it's going to go through A because it's a 0 there. Then it's going to reach a minimum point, it's then going to go around, it's going to come up through B, as it's another 0 there. It's going to reach a maximum here, it's going to come back down, it's going to touch the x-axis at C, it's not going to cut it, and then it's going to come back up and increase from then on. And that is everything we need to do for our derivative. Now for our second derivative, we've got to identify our inflection points. We've already done that, and we're going to mark that as 0. And then we've got another inflection point there, that'll be another 0, and we've got another inflection point there, which will be our third 0. Now we need to draw a sign diagram, so that's going to be where we use, and well, we've got 3 zeros, and they'll just match going across. So we're going to use our curve on f of x. So here we've got a concave curve, so we're negative. Then from this point here to this point here, it'll be a convex curve, so it'll be positive. Then from here to there, it'll be another concave curve, so it'll be negative. And then after that, it'll be a convex curve, so it'll be positive. And so that's our sign diagram of f double dash of x. Now if we consider our inflection points of the derivative this time, so we're not worried about the inflection points of the original curve anymore, we're worried about what they are on the derivative. So if I come around here, there's some sort of inflection point at about here, and it's going convex to concave. So this will create a maximum. And in this region, the second derivative is above, so it'll be a maximum somewhere around about here. And then if I look at there'll be another inflection point around about there, and this time it's going from concave to convex. And in this region we can see that it's below the x-axis, so it's creating some sort of minimum there. And so then if I draw it, well, if I look at my sign diagram, it starts below. I go below, cuts at that point, comes up to form a maximum, then it goes around, it comes down to cut again, and then forms a minimum, and then there's another inflection point there, so it's going to have to come up and go through, and it finishes above. And so that's my second derivative. Okay, so it's a matter of just following the process. Now it can be a little harder when we're dealing with asymptotes, but let's just work our way through it. So horizontal asymptotes only occur as you go to positive and negative infinity. So we see on this graph, as we're going across this way, it's asymptoting to 0 from above, and this way it's also asymptoting to 0 from above. So these horizontal asymptotes produce asymptotes to the x-axis. So any horizontal asymptote will produce an asymptote to the x-axis, and the sign diagram will determine whether the asymptote is to the x-axis from above or below. So we've got to draw our sign diagram of our derivative. Now it doesn't cut the x-axis anywhere, but there are a couple of vertical asymptotes, namely at positive 2 and minus 3. And let's remember that we indicate that by dotted lines on our sign diagram. Okay, so the derivative to the left of minus 3, well, it's going up, so it's positive. Here, it goes up to a certain point and then goes down. So there's a stationary point here. Let's say that's at about minus a half. And so that will be minus a half. And so it's positive to the left, negative to the right of minus a half, and then to the right of 2, it's going to be negative because it's decreasing for that whole time. Okay, first thing we should do, take a stationary point, make it a 0. Okay, now, vertical asymptotes are going to occur at the same point, and again we use a sign diagram to determine if it's going down or going up. So here, my derivative is positive, so it's going to be going up at my vertical asymptote, and it's going to be asymptoting to 0 from above. So it's going to look very much like the original function, something like that, because in this region the derivative is positive. Here the derivative is positive, so it's going to have to be a vertical asymptote from above. So it's going to have to be something like this, coming down to my 0. Now on the other side of a half, it's negative. So it's going to have to be going down off to infinity, something like that. Notice that the sign diagram of my derivative is telling me everything I need to know. Now I've got another vertical asymptote at 2 where it's negative, so it's got to be coming from below. So it's negative there, so it's going to be coming from below, and it's also going to be approaching the x-axis from below, because again the sign diagram of my derivative is negative, and it's going to look roughly something like that. And so that's my derivative. Now drawing the second derivative is quite similar. So we are again going to need a sign diagram. So my sign diagram, well, it's going to be minus 3 and 2. Now on this one there are no inflection points anywhere, but we still have our vertical asymptotes. So to the left of minus 3, it's convex all the time, so it's going to be positive. Then here it's concave all the time, then we're back to being convex all the time. So we again use our sign diagram. So here it's positive, So it must be going up to infinity at this vertical asymptote and must be approaching the x-axis from above. And so it's going to look something like this. Here, it's negative all the time, so it must be approaching both vertical asymptotes going down to infinity. And it would look something like this. Be very careful that when you draw it approaching vertical asymptotes, you do not cross over the vertical asymptote like I have done. That will cause you to lose a mark. So don't cross over the vertical asymptote, that's very important. And here to the right of 2 is positive, so it must be going up to infinity there and approaching the x-axis from the positive region. And so it'll look something like that. Okay, now we're going back the other way. We're drawing the function from the first derivative. So this, I will be honest, this does get a little bit harder, but we really just need to keep everything in mind and follow the process. So the very first thing we're being asked to do is we're being asked to draw the sign diagram of the first derivative and the second derivative. Now, we're given the derivative and we're going to be asked to draw the original function. And this is going to involve some asymptotes. Now, it does suggest that here it's probably worth mentioning that there is a maximum on our derivative, so that's going to be an inflection point on our original function and a 0 on our second derivative. So we'll just mark that in there. Okay, now if we look at our derivative, well, we're only shown it for x greater than 0, so I should probably just include that. And it's negative for the entire region. Okay. For my sign diagram of f double dash of x, well, my stationary points of the graph are going to be 0, so it's going to be 0 at this point. And increasing and decreasing regions of my derivative are going to tell me about positive and negative. So here it's coming down, there it's going up, so it's negative, positive, like that. Now, the sign diagram of my derivative tells me the type of stationary point. Well, there is no stationary point on this one, so that doesn't even matter. So there's no stationary points on my original graph because there is no zeros on my derivative. Now,